right. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Okay, so what can I do for you today?
I actually had a question about the test review that we had last night. It was question number 3.
Okay, hang on just a minute. Let me pull that up if you'd like.
Yeah, that'd be awesome.
Let's see here. Okay, give me just a minute. Come on.
Every other question on the review I could figure out. That one I couldn't, and I'm not sure.
Okay, let's see here. Okay, other section. Here we go. So review. Almost there. Number 3. Okay, let's take a look at number 3. Okay. I know what's, I bet I know what's wrong. Let me ask you this. So when you plotted those lines, did you use the box over here that has points, or did you use the box over here that has lines?
I did lines.
You did lines.
I'm not sure. I should.
Because here's what, well, let me do this, okay? We're going to come back to your problem here in just a minute. And let me take a look and I'll show you what I'm talking about. You may not have done this, but often it's the problem. Okay. Let's see. Okay, so can you see this number 3 here from WebAssign? Hello, Davis? Davis, are you there?
Yeah, sorry, my internet just went out for a second.
Oh, okay, okay. So can you see this problem number 3?
Yeah.
And I'm not actually going to do number 3. I just want to use this screen. Here's the problem, okay? And this is, I don't know this for a fact, but it seems to be the deal. So they're wanting us to graph 2 inequalities, okay? So let's say we're just going to graph 1 inequality, okay? If we use a dot, and then we plot a dot, let's say here and here, okay? And then we come back and say, oh, let's put a line there, okay? Or maybe I need to go back here. Let's see, let's put a 3rd dot there. No, that's not working. No? It's not doing what I thought it did. So let's go back to your problem. And it was number 3. What I've noticed is sometimes sorry, I'm not brain dead. It's just that what I thought was wrong isn't what's wrong, so I'm not sure. Did you, okay, can you see on your screen there's a green area shaded?
Yeah.
Okay, did you shade an area?
Yeah, I shaded the top area. I'm not sure. I don't know why.
Oh, so you shaded this part up here.
You shaded the wrong part.
Okay, okay. So let's go through this. Now, in here, the wild goose chase I was leading you on, I always thought that maybe if you plotted specific points and then it was supposed to be an inequality that wasn't equals, you had those solid dots on a dotted line. And so WebAssign said that's wrong. But my problem is I can't see what you did wrong in terms of what you shaded there. Okay, so anyway, so let's do this. Let's take a look and give me a second here to set this screen up like I want to do here. Just give me a minute. Okay, where are we here? Okay, so now can you see the whiteboard on the right and WebAssign on the left?
Yeah.
Yes? Okay. So
Yeah.
let's take it from 7x plus 5y less than 35. And that is this line right here. Okay. Do I need to convince you of that, or are you okay with that?
No, I believe you.
Okay, let's take 0, 0 and use it as a test point. So we'd have 7 times 0 plus 5 times 0 less than 35, 0 less than 35. This is true. So for this line, it's going to be there. Okay. So already I can see that you're in trouble choosing this.
Yeah, but I did it like every other. It wasn't a problem with any other of the problems, so
Yeah.
that's why I'm confused, because it went fine with any other of the equations that I had graphed, but
yeah, I don't know if you just put in some wrong numbers or something, but
yeah.
but it should be. I mean, already it's going to be shaded here and here.
Yep.
Without even doing the other piece. So there's no way it could be here.
Yeah. I don't even know why it's on the top.
Yeah, I don't know. Mystery solved, hopefully.
Yeah.
You good with that one?
Yeah, I think
Okay.
we're good.
What else? Either you or somebody else. I'll go ahead and leave these screens up here in case you've got other questions on WebAssign.
Hi, yeah, I have a question on the actual homework 14.3.
Okay, hang on just a second. Edith, do you remember offhand, or if you are in 2440 or 2445?
I don't.
That's okay. Let's see. Here we go. 14.3.
Yes, and it's question number 8.
Okay, and it looks like you've got it right, but you still got some questions about it.
Yeah, so I initially got a negative, and I'm wondering why it's actually a positive, not a negative.
Okay. So find the specified term of a geometric sequence. So we're going to use a sub n equals a sub 1 times r to the n minus 1 power. Okay.
Mhm.
Find the specified term. We are told that a sub 1 is 1/2. A sub 2 is -3/2, and a sub 3 is 9/2. We're supposed to find a sub 9. Okay.
Yep.
Now, we don't know what r is yet, but in a geometric sequence, you can find r by taking any term in the sequence divided by the previous term. So I'm going to take a sub 2 divided by a sub 1, which is -3/2 divided by 1/2. Okay, so far?
Yep.
But that's equal to -3/2 divided by 1/2, which is equal to -3/2 times the reciprocal, which would be 2/1, right? Dividing by a fraction is like multiplying by its reciprocal.
Yes.
This reduces down to -3. So R equals -3. Okay.
Yeah.
So now, using this formula, A sub 9 equals A sub 1, which is 1/2 times -3 to the 9 minus 1 power.
Yeah.
Oh,
Yeah.
I already know what you did. This is 1/2 times -3 to the 8th power. You said that you got a negative answer first.
Yes.
Okay, did you put -3 to the 8th power in your calculator and get a negative number?
Yeah, that's what I did.
Okay, here's the problem. If you put this into your calculator, you're going to get a negative number. You need to quantify, you need to suck that negative sign into part of the base.
Okay.
So if you do this first one, you get -3 to the 8th power, you get -6561. But here you're putting parentheses around the negative as well. And this would give you positive 6561. Okay, and we're not done yet, but that's perhaps what you did wrong. So here it takes 3 and raises it to the 8th power and then applies the negative sign. If you want the negative to be part of the base, you got to group it. Does that make sense?
Yeah, I got it now.
Right. So now we've got what, 1/2 times 6561, which is 6561 over 2. And there's your correct answer. So that's why you got the negative sign when it should have been positive.
Okay.
Right?
It clears it up. Thank you.
Good. Anything, anybody else? This is what we're doing. Just whatever questions you've got. All right, then let's do this. Let's go back and let's take a look at just some highlights from each section. Okay. Yeah, let's see here. All right. This is like section 3.7. So what do you need to know about graphing in section 3.7? You need to know how to graph properly in WebAssign. So I've got this inequality, which isn't going to work until I click on that. Okay. Y is less than or equal to -4x. Okay. So already I know that my line is going to be solid because it includes the equals to. Okay. I need to plot a couple of points to establish where that line is. So I'm going to take a look at the equation. Then I'm going to find a couple of points. Now, I keep using X and Y intercepts, and that's fine unless we run into the problem that I'm going to run into here in just a minute. Okay. So if I let Y equals 0, I get 0 equals -4x, divide both sides by -4, and we get x equals 0. Well, this problem goes through the origin. So I can't use this value because I'm going to get the same point, 0, 0. So I got to pick something else. So how about we'll let x equal 1. All right. Are you okay with that? Any questions why I did that? Okay. So I've got y equals -4 times 1, y equals -4. All right. So now I'm going to come over here and I'm going to click on the line. I don't want the ray or the line segment. It's got to be the line, and I've got to click on it until it's blue. Otherwise, it doesn't let me do things like I want to do. At least that's a, let's see here. Now it won't let me undo it. Come on. There we go. Okay. All right. So I've got 0, 0 and 1 -4. Now I'm going to accidentally or deliberately put it in the wrong place to remind you, if you've got like a fraction or something, an improper fraction, and you can't get it to graph it, you can come over here and you can correct it by going into the ordered pair, and you can put in, you know, let's say it needed to be -4/7 or something like that, okay? Or -4/7, okay? Now, that isn't the right answer, but my point is you can fix it over here, okay? Any questions about that? Do I want it dashed or solid? I want it solid because it includes the equals to. So this is the line so far. Now, I've been using 0, 0 as a test point. That works great if the actual line doesn't go through the origin, but here it does. So I've got to use something different. How about let's use 3, 3, okay? So our test point is going to be 3, 3. So if I put that in here, I get, is 3 less than or equal to -12? No, that's false. So this point up here, 3, 3, is not part of the solution. So where is the solution? It's on the other side of the line. Okay. And let's see if that's correct. And it says it is. So again, anything about that process? I have my inequality. I look at just the equation. I find a couple of points. I plot them. It forms a line. I determine whether the line is solid or dot or dashed based on whether it has an equality or just a less than or a greater than. I pick a test point that's not on the line. If it's true, then it's that side of the line I shade. If it's false, it's the other side that I shade. Are we okay with this? All right. So that's basically what was in 3.7. Let's take a look at 4.5. So now we're graphing. Oh, there's points on there. I think I was messing with that earlier. So now we're graphing a system of inequalities. We're going to do the same thing we did earlier twice and then find where they overlap. Okay, let me see something here. Yeah, let's do this one. Okay, and again, as I'm doing this, if you want to see more examples of something I just did, or you've got a question, please jump in. Okay, I'm doing this for you, not for my own amusement. Okay, so 7x plus 5y less than 35. Okay. So then I'm going to look at the related equation, 7x plus 5y equals 35. I'm going to find two ordered pairs. Again, I'm just going to stick with the intercepts. I don't have to, but I'm going to. If y is 0, we get 7x plus 5 times 0 equals 35. So 7x plus 0 equals 35. 7x equals 35. Divide by 7x equals 5. I think we did one just like this a little while ago. Okay, we all right with that? If x is 0, 7 times 0 plus 5y equals 35. 0 plus 5y equals 35. 5y equals 35. Divide by 5, y equals 7. Okay, so I'm going to come over here, click on the solid line, 5, 0, 0, 7. But I see that I don't have equals to, it's just less than. So my line needs to be dashed. Okay, if it had an equals to below there as well, then it would be solid. All right. 0, 0 will make a good test point. I don't know if it's any good saying this because my guess is that if you're here, you've been watching all my videos, but in case this is the first time you've come in to watch the video, I got a lot of students asking me questions about graphic. And then I'd say, have you watched the videos? And they'd say, no. Okay. Just because you can't make the live sessions doesn't mean you should skip the videos. There's stuff on those videos that you only get there about WebAssign, okay? So watch the videos, then if you're still confused, or at least come to the live meetings, if you're still confused, then get in touch with me, but don't just, you know, you're supposed to watch those first. Okay, anyway, enough of that. So 0, 0, let's see, 7 times 0 plus 5 times 0 less than 35. Yeah, I know we did this one. 0 is less than 35, that's true. So we're going to fill it on that side, okay? So I'm going to remind myself by saying it's on that side. So we're halfway through the problem. We have the graph of 7x plus 5y less than 35. All right. Now we're going to start all over and look at the second one. Which is 5x minus y greater than 5. Okay, the related equation. Yeah, is this the exact one I did earlier? Yeah.
Yeah.
Yes.
Okay, sorry about that. You want me to do a different one?
I actually kind of want to see how you finish this.
Okay, great. Yeah, sorry, because not everybody has the same numbers. Sometimes, you know, everything that's in red could be different on other people's problems. So I never, you know, yeah, anyway. Okay. So we're going to look at the related equation. I'm going to find the x and y intercepts. If y is 0, I get 5x minus 0 equals 5. 5x equals 5, divide by 5x is 1. If x is 0, 5 times 0 minus y equals 5. 0 minus y equals 5. Negative y equals 5. Divide by negative 1. Y equals negative 5. Okay. And if I get going too fast here, yell at me to slow down. All right. So now I'm going to come back over here. But notice when I go to graph another line, the shading disappears. That's just how WebAssign works, which is why I made myself this note to remind me what's going to happen. I've got 1, 0, and 0, negative 5. But this also does not include equals 2. So line 2 has to be dashed as well. Okay. Now, for line 2, again, I'm going to use 0, 0 as a test point because it looks very nice there. Test point 0, 0. So 5 times 0 minus 0 greater than 5, 0 minus 0 greater than 5, 0 greater than 5, that's false. So for the second line, which is this one, okay, as I mentioned, I wish there was a way to color code these, but there isn't that I know of. 0, 0 is not good, so it's over here. Okay, so that's what I would shade for just that second line. Okay, so I'm going to make a note to myself here. It's going to be below that line. All right. Now I've got to look at the intersection of the two. So let's go back and get rid of all the fill. Okay. So for this line, which is this one, it was here and here. For this line, which is this one, it was here and here. So where does this and that overlap? Down there. Okay. You all right with that? Any questions on that?
Would it be okay to do maybe a couple more samples of this?
Sure. In fact, I'm going to do one more thing with this. Now that I know where the solution region is, let's pick a point in there and plug it into both inequalities. It should be a solution to both. So how about this point right there? How about 3, 0? Okay. In fact, let's go to an entirely different colored pin now. How about, let's do green. Okay. So we're going to take 3, 0. And we're going to plug it in there, and we're going to plug it in there. Okay. If that is the solution, it should work for both of those. All right. So 3, 0 in here would be 7 times 3 plus 5 times 0 less than 35. 21 plus 0 less than 35. 21 less than 35, and that's true. So it checks there. Now let's put it in here. Let's see, 3, 0. 5 times 3 minus 0 greater than 5. 15 minus 0 greater than 5. 15 greater than 5. It checks there. Okay. So after I found the region that was the solution to both, I picked a point inside, not on the line, but inside, and it was a solution to both. You okay with that?
Yes.
All right. And you wanted another example? Do you want me to do this one, or do you want me to just pull something else out and do that instead?
That would work.
This one? Okay. So let's see, let's go back to, we're going to start with black for our first inequality, and we've got 9y less than or equal to x. Okay. So we're going to look at the related equation. And I'll find the x-intercept by setting y equal to 0. 9 times y equals x, x equals 0. This one goes through the origin. You can always tell if one goes through the origin if in the equation or the inequality there's only 2 terms, and one of them has the variable x and one of them has the variable y, and there's no constant terms, it's going to go through the origin. How about let's let x equal 1. Okay, so then I get 9y equals 1, divide by 9, y equals 1/9. All right. So now I'm going to come over here and get the solid line. 0, 0, 1, 1/9. There's no way it's going to let me do that, but I can fix it right over here. Okay. Oh, it needs to be solid as well. So far so good. That's why you need to watch these videos that I'm making, because otherwise people won't know how to get that to work. Just saying. Okay. It's not all about me. My point is, though, there's information that it's hard to figure out. I had to ask some of my colleagues for some help in WebAssign early on because I couldn't figure it out either. All right, so there you go, confession time. We're going to start over now with the red one. And we've got y is greater than 9x. Okay, so again, I'm going to look at the related equation, y equals 9x. And again, I'll find the or the x-intercept, but I'm going to have to find something different, I can tell already. Let's see here. If y is 0, 0 equals 9x, divide by 9, divide by 9, 0 equals x. So we get the origin. And then let's use, how about x is 1? Okay. So y equals 9 times 1, y equals 9. So for our second inequality, we have 0, 0, and 1, 9. Now, this one does not include the equals to, so the second line has to be dashed. Okay? Any questions about that? Now, I can't use 0, 0 as a test point because both lines go through 0, 0. So let's go back to the first one, which is the solid line, and let's see, we use 3, 3. Let's use 3, 3 again. That'll work right there, 3, 3. Okay. And I got to change the color back. Come on, here we go. Okay, so test point 3, 3. Now, I noticed last time I found I used the test point after I had just done one of the lines, and this time I did both lines first. It doesn't really matter. You got to get those lines on there. So in other words, you can do one of them and test it, or you can do both of them, whichever way. Okay, let's see. What do we got here? 9 times 3 less than or equal to 3, 27 less than or equal to 3. That's false. So for the solid line, 3, 3 is not correct. So it's not on the top, it's not above the solid line, therefore it's below the solid line. So the fill would be here and here. Okay, and I'm going to make a note of that for the solid line, the fill is below. Okay, there. All right, let's go to the second line, to the red line. And let's see, tell you what, let's use 3, 3 again, because it's not on the line. So test point 3, 3. So we get 3 greater than 9 times 3, 3 greater than 27. That's false. So 3, 3 is not a correct test point for the dotted one. So it's not, now that the dotted ones are the dashed one, it's not over here. So it's not on this side of the dashed line, which means it's got to be over here. Okay. So then that fill would be here and here. And to remind me, okay. So let's go back and get rid of these. So for the solid line, it's here and here. For the dotted line, it's here and here. So where do they overlap? Down here. Everybody see that?
Yes.
Okay. Any questions about this problem? Anything you want me to go back and do there again? Are we good to go on to something else, or do you want another example of this?
I think I'm good. I don't know about anybody else.
Okay, well, speak now or we're going to go on.
Good.
I'm good too.
Okay, we're good. Let's go on. So next we go to section 14.1, which was factorials. Okay, so let's see
I have
here.
a question on one of the test reviews.
A specific one?
Yeah.
Okay, so do you want us to look at yours specifically, which we can do?
Yeah, it's number 15. But I got it right, but I had trouble finding the answer.
Just to, does it happen to be the same one I've got here?
No.
Okay, all right. Give me just a minute here and we will find that. Okay. In fact, what I need to do is I need to stop sharing that. Okay, while I find it, so everybody doesn't see everybody else's work, because that's not a good thing. Come on. Okay, here we go. And We're talking the chapter review. And you said, was it number 15?
Yes.
Okay. So can you see number 15 and the whiteboard as well?
Yeah.
All right. And let me see here. Find the first term of a geometric sequence if it has a common ratio of -3 and the ninth term is 243. Ah, yes. I wondered when this was going to come up. Because now we're working backwards. They don't give us the first term. So what do we got? We've got the geometric sequence formula. A sub n equals a sub 1 r to the n minus 1 power. We know that r is -3. And we know that a sub 9 is 243. But now we're trying to find a sub 1. Typically what they do is they give you a sub 1 and ask you to find a sub 9, but not so in this case. All right, now consider this. A sub 9 equals a sub 1 times r to the n minus 1 power. In other words, a sub 9 equals a sub 1 times -3 raised to the 8th power. Okay? You see what I did there?
Yeah.
But I also know that a sub 9 equals 243. So here we go again with finding two different ways to describe the same thing. So that means this equals that. Okay? So now a sub 1 times, now here again, -3 to the 8th power, it's not -3 to the 8th power, it's -3 in parentheses to the 8th power. So on my calculator, in fact, I've got it right here. This is 6561 equals 243. So a sub 1 times 6561 equals 243. Let's divide both sides by 6561. So a sub 1 is 243 over 6561. Now, can we reduce that? Let's find out. Okay, here's a little review that goes way, way, way back in arithmetic. And that is to figure out what goes into a number. 243. Does 2 go into it? No, it doesn't. How do you know? Because it's not an even number. Does 3 go into 243? Do you remember how you tell if 3 goes in? Yeah, get the sum of the individual digits. So let's see. 2 plus 4 plus 3 is 9. If 3 goes into the sum of the digits evenly, then 3 goes into the original number. So we're going to divide by 3 on top. Okay, 243 divided by 3, and we get 81. Does 3 go into the bottom? Let's see. 6 plus 5 plus 6 plus 1 is what? 12, 18. Does 3 go into 18? Yes. So we'll divide the bottom by 3. 65, 61 divided by 3. And we get 2187. Well, we've reduced it down, but guess what? That's still not reduced to its final form. Does 3 go into 81? Yes. Does 3 go into 2187? Yes. Again, if you add up the digits. So what do we got? We got 81 divided by 3 is 27, and 2187 divided by 3 is 729. Oh man, 3 goes in again, doesn't it? This is 9 over, let's see, that divided by 3 over 243. 3 goes in again. Wow, there's just too many 3s here. And then 3 goes in again. Now, is there an easier way to do this? Yeah, probably. Tell you what, let's put 243 divided by 6561. Well, I get this horrible 0.037 repeating. How can I turn that into a fraction? And can I turn it into a fraction? Well,
Yeah.
how do you do that?
With the little arrows on the calculator.
Yeah, your fraction key. And I'm not even going to go into all that at this point, but there's a way to do that with your fraction key. But I'm actually more interested that you can do this process than you can shortcut it with the fraction key. So that's why I'm not going to spend time on it. It's like, oh man, he set us up and then he didn't show us. I know. Of course, another question I'd have is, what if you put in, instead of 1/27th, you put in an answer that wasn't reduced? Would it take it? I don't know. Anyway, but do you see where we get the answer? We okay with that?
Yeah.
It was all back to the whole thing of getting two ways of describing the same thing. Oops. So that you can form an equation. All right, what else? Let's go back, then I'll go back to looking at the,
I have a question.
yes.
I was wondering if you can show us how to do a geometric sequence that says to find 3 numbers, but it only gives you a formula, not what a sub 1 is, a sub 2 is. For example, let me exit out my screen. Let's see, it was right here. So how about one where it says starting with the first term and list in sequence order, and then it just gives you the formula and you have to find the 3 numbers.
So
And
it tells you it's a
in the
geometric.
formula, and the formula gives you 3 and a 2. So a sub 1 would be 3 and the R would be 2.
Oh, okay. And you're supposed to find the first 3 numbers?
I want you, the 4.
The first 4?
Yeah, can you guide me to how you do that?
Yeah. What's 3 times 2? What's 6 times 2? What's 12 times 2? Because to get to the next number, you just multiply by the common ratio.
Oh, okay.
So that one wasn't complicated, but
Oh, so then basically the only thing you do would just do the R. Oh,
Yeah.
Okay.
now, what if it said, what's a 243? Obviously, you wouldn't want to sit there and go a sub 5, a sub 6, a sub 7, a sub 8. So let's find a sub 243, okay? So a sub 243 would be 3 times 2 to the 243 minus 1 power, which would be 3 times 2 to the 242 power. So then on your calculator, you're going to go 2 to the 242 power, and then times 3, and I get 2.120216478. Wow. Times 10 to the 73rd power. I get some awful number. But my point is, when you're just finding consecutive numbers in a sequence, on geometric sequence, you just multiply by R each time. But if you've got one that's way out there, then you've got to come back here to use the formula. Okay? What else?
Thank you.
You betcha. Well, let's see.
I think she was talking about because I remember that question. It was number 4 on 14.3.
Okay, do you want us to look at that?
Yeah, maybe that's the one I think you're talking about because it gives you a formula and it gives you 3 times 2n minus 1.
Okay. All right, so let's see here. We're gonna go back to home and Messenia. Let's pull yours up here. You said it was in 14.3.
Yeah, it was number 4.
Oh, yeah, I see it there. Okay. Okay. So fill in the blanks, starting with the first term and listed in sequential order, the first 4 terms of the geometric sequence defined by, oh, okay, so they're actually giving you a specific formula. Remember we looked at that yesterday or the day before, that if it just says an arithmetic sequence, you're going to use that. If it just says a geometric sequence, you're going to use that. But if it gives you a specific formula, then use that one. And this formula that's listed in the problem is that. Okay. So I see what you're saying about that a sub 1 is 3 and r is 2. And you could get that out of here, but it just kind of gives it to you in this form. So how would you find that? Well, a sub 1 would be 3 times 2 to the 1 minus 1 power, which is 3 times 2 to the 0 power. What's anything to the 0 power equal to? Nobody remembers?
1.
1. Good. So that's how you'd get a sub 1. Okay. We okay to go on?
Yeah.
A sub 2 would be 3 times 2 to the 2 minus 1 power, which is 3 times 2 to the 1, which is 3 times 2, which is 6. A sub 3 is 3 times 2 to the 3 minus 1 power, 3 times 2 to the 2, 3 times 4 is 12. And then, of course, you can see what's happening there. It's doubling, right? Oops, that's as far as.
Yeah.
Yeah. So this one, they're giving you the formula ahead of time and saying, use that formula to plug things in. Okay. What else? Well, we looked at 3.7 and 4.5. We worked with factorials a little bit. Do you need anything more to do with factorials? Anything there you want to look at? Okay. How about arithmetic sequences? Do you want any problems? Anything else with arithmetic sequences?
Yeah, we can go over it.
All right. Let's see here. Okay. Let's see here. Okay, let's take a look at number 10. All right. The first 3 terms, can you see that? The first 3 terms of an arithmetic sequence are 8, -8, -24. Find the 101st term.
Yeah.
Okay. So arithmetic sequence, therefore it's a sub n equals a sub 1 plus the quantity n minus 1 times d. We know that a sub 1 is 8, A sub 2 is negative 8, and A sub 3 is negative 24. Okay. We need to find A sub 101. Okay. Well, I need to find D. So to find the common difference in an arithmetic sequence, you take any term in the sequence minus the previous term. With a geometric, you divide. With an arithmetic, you subtract. So let's see, that would be negative 8 minus 8, which is negative 16. So the common difference is negative 16. Does everybody see how I got that? All right, let's
Yes.
check it out. What's 8 minus 16? It'd be negative 8. What's negative 8 minus 16? It'd be negative 24. So it works. Okay, so now we know the first term and the common difference. We're ready to use this formula. A sub 101 equals A sub 1 plus n minus 1 times D, which is 8 plus 100 times negative 16, which is 8 plus negative 1600, which is negative 1592, I do believe. Yay. Okay. Any questions about what I did there? If I went too fast, let me know. I'll go back and redo stuff. We okay with that?
Yeah, that was good. Thank you.
Okay. Do you want some more to do with arithmetic sequences?
Could you do the 11?
Which 11? The one that's in front of us here?
Yeah.
You betcha. I thought you'd never ask. All right. Find the common difference D of an arithmetic sequence. So A sub n equals A sub 1 plus n minus 1 times D. Make sure you're using the right formula. I'll have students mix things up and they'll use the geometric one when they should use the arithmetic one and vice versa. So read carefully. Okay. We know that the first term is negative 569. We know that the 23rd term is negative 679, and we want to find the common difference, okay? So we're going to set up an equation. We're going to use A sub 23. So A sub 23 equals A sub 1 plus 23 minus 1 times D. A sub 23 equals negative 569 plus 22D. 23 minus 1. But we also know that A sub 23 is negative 679. So once again, we can create an equation because this equals that. You seeing that? This whole idea comes up over and over again in this section. Okay, so I've got negative 569 plus 22D equals negative 679. I'm going to add 569 to both sides. Let's see, negative 569 plus negative 579, my bad. Negative 579. Let's try this again. Negative 679, excuse me, I should have just done it in my head, but whatever. Plus 569 equals negative 110. Okay, finally. Divide both sides by 22 and D equals negative 5. A mistake that I've seen students do time and time again in a test is they don't look at the whole thing. For instance, here, they already give you D, but I'll have students do this. They'll write D equals -5. And then submit answer. And it says your answer cannot be understood. It's because you put things in there that were already there. My point is pay attention to what's already given, to what you need to put in there, okay? All right. What else? Any other questions, things you want me to look at? So you've got graphing inequalities, graphing systems of inequalities, factorials, arithmetic sequences, and geometric sequences. That's what your test is going to be over, okay? You get 75 minutes for your test, unless you know otherwise. Once you open it, the time starts. You can't work on it and then close it and come back 2 hours later. You got to start it, finish it. So set aside an hour and a half where nobody's going to call you, turn your phone off, where nobody's going to distract you. You got kids, get somebody to take care of them, whatever. You got to finish before 11:59 tonight. Don't start at 11:30, okay? Anyway, any other questions?
How many questions are on the test?
I honestly don't remember, but you know what? Give me a second and I'll look. Let's see here. Okay, let's see here. There are 12 points. And looks like there's 12 questions. Okay.
Okay, thank you.
You were hoping I'd show you the test, weren't you? Just kidding. All right. Well,
Can you
yes, go ahead.
do number 12 on the review?
Okay. Do you want me to do specifically yours or does it matter?
It doesn't matter.
Okay. Let's see. Okay, and who asked for that? Was it Juliana? Are you the one that, no, who asked for
Yeah,
it? What?
Juliana.
Juliana, okay. Right, let's see here. Pull yours up here. Come on, Juliana. You're in the other class. Okay, which one was it you wanted from the review?
12.
12 on the review, okay. Okay. Find two arithmetic means between 2 and 31. Okay. So arithmetic means we're going to use the fact that a sub n equals a sub 1 plus the quantity n minus 1 times d. Okay. We know that the first term is 2. We're supposed to find two arithmetic means, and we know that the last term is 31. We know there's a total of 4 terms because we have a first, we have a last, and we have 2 in the middle. Okay? You all right with that?
Yeah.
So now I know that a sub 4 is a sub 1 plus 4 minus 1 times d, which is 2 plus 3d. I also know that a sub 4 is 31. So now we get 2 plus 3d equals 31. Okay? You all right with that?
Yeah.
Subtract 2 from both sides. 3D equals 29. Divide by 3, D equals 29 thirds. Okay, now, how do we get from A1 to A2? We add the common difference. So 2 plus 29 thirds would be 6 thirds plus 29 thirds. Now, what am I doing over here? I'm taking 2 and multiplying it by 3 over 3 to build it up to a fraction that has the same common denominator, okay, which gives me 35 thirds. You all right with that?
Yeah.
How do I find a sub 3? I take 35 thirds plus 29 thirds, which is what? 64 thirds. Now, to check my work, let's see what 64 thirds plus 29 thirds is. That would be 93 thirds, which is 31, so it checks. So what are my two arithmetic means? 35 thirds and 64 thirds. And again, you have to use improper fractions, not mixed numbers. Okay?
Thank you.
Yeah, I'm wondering if you misread it as geometric means.
I just didn't understand it.
Okay, because the fact that you've got a square root here makes me wonder if that's what you did. But anyway, okay. So, what else? Anybody? All righty. Well, then we'll close this session. I'll stop the recording and good luck on your test.